Alright guys, we got a pretty easy one right here. Depending on how you look at it, it actually, in a real world setting, would be extremely complicated. But as far as the book is concerned, we're just trying to learn structure. So it's overall pretty simple, I think, what they're asking for. Here's the pseudocode. So let's go over to this right here. And what we're trying to do is, I've got a word in mind, and I'm asking someone to guess that word. And if their word is alphabetically, it comes after my word in the dictionary, like in alphabetical order, it's after. I would just say your word, comes after the actual word. And if it's sooner, then I'd say your guess comes before the actual word. So kind of having them flip back and forth through the dictionary to find it, and each time they make a guess, I'm saying, nope, you haven't gone far enough, or your word has, you've gone too far, so flip backwards in the dictionary. So that's basically all we're looking at, is the structure of how that would be done. If you actually coded a program like this, I'm beginning to realize that it would be a monster. It would consume your life, and your brain would start to leak out of your ears. But it's a lot of fun. If you're a glutton for pain and stress and you just love code. But let's see. We'll have start, and then we have input guess. While the guess is not equal to the word, that's true. If guess is less than word, that all that means is that the less than says that your guess alphabetically comes after the actual word. I figured that out with the program on the other page. But you could also reword this as if guess comes after word in alphabetical order, or however you want to put that. If that's true, then you say the actual word comes before your guess. If this is false, it's the reverse. The word comes after your guess. Then you have a place for input. You'll loop back around to make sure, check, and if they guess it, then you guessed it, and stop. So not too difficult, very basic. But I had a little bit of fun with this. A lot of stress, a lot of tears, a lot of happiness when I figured things out. But it's an incomplete program up here. I'll get to that in just a minute. But you don't have to go through the rest of the video when I'm doing this. That's just for those of you that want to see a partially made program that's on its way to being a program that would actually be reasonable for this kind of problem. But we've got pseudocode here, and so we've got start, input guess, while the guess is not equal to the word. If guess is less than word, output your guess comes after word. Else, output your guess comes before word. End if, another check for your guess, or wait input, end while, and stop. And I put this here because it's a note to say this is what you're going to be using in the code in order to figure out alphabetically where your word falls, where your guess falls compared to the actual word. So you're comparing the actual word to your guess, and this less than applies to your guess. 0 is used as kind of like a way to see if it's alphabetically sooner or after, or if it equals. So if you had equals here, that means these two words match. And this obviously means that your guess is like, I don't know, maybe it's sun and the word is dog. And so if this were greater than, your guess might be cat and this would be dog. So that's all that's doing right there, is a note for that, and the reason why I've used less than. Because in the code here, and let me just give you the pseudocode real fast, in the flowchart again, and feel free to pause it at any point and check it out. Also, just make sure that this is right. I'm not flawless, so if you find that I've done something wrong or you can do it better, please do it your way. Be satisfied, because here and there I might make a few errors or maybe code something that's not really the most efficient way. So always check that and be happy with where you're going with the assignment. And if all else, it's a helpful place to start. Anyway, for those of you who are interested in what this is all about, I'm not going to get too detailed because it's still complete chaos. I'm just really starting to figure things out, and I might not make very much sense trying to explain the spaghetti sauce that's going up inside my head right now. Um, it's a lot to handle, and you get to the point where you just your brain starts to twist and um, puree and come out of your ears and stuff. So basically, we've got two variables here, technically three so far, or four. Sorry, four. Imagine these as arrays. It only understands, and well, I put S1 and S2 like string 1, string 2, but it technically only understands this as individual letters. But we have to do that because later on I want the program to be able to check for each letter in both words. So the first letter in this word, the first letter in that word, and compare the alphabetical order to give you like help to say change the first letter of your word to this, change the second letter of your word to this, like go back 5 spaces or go forward 20 spaces, just a little bit of help. So that's why these are declared as this character, and they're more of arrays. This right here, this L and M, I'm just declaring these variables here because later on I'm going to convert these to string values. I'm going to tell these to understand what's in here as a whole and tell me like how long this word is, how many characters long it is. Right now as is, it can't understand that. So I'm going to convert it to where it can understand it, and I don't want to write out that long code every time, so I'm going to assign it to these two. So the first word, length, is going to be L, and the second word, the guess, is going to be M. So that's where we have down here. I'm taking the actual word, which is dog, and I'm saying understand this word as a string now, like understand it in its fullness, and now you can tell me how many characters long it is. Same with your guess, and your guess, the length of your guess will be defined by M. So I'm just making it easy, so now we don't have to write all of this out every time. We can just put L and M. So anyway, back up here we've got a way to input your guess. Right here, I'm just letting you know that this program is not done yet. I don't want the user to be able to type in numbers, and imagine if you want them to be able to type in sentences. Think about the big picture. You could actually make a program that if you've got a book and you want to compare it to a supposed copy of that book, and you've got them both in digital form, and you want to cross-check everything to make sure there's the right punctuation, the right letters, the right spaces. You could do that, but that would take some extra code to say, for this program specifically, I don't want to allow numbers. But think about the big picture. You would need some coding to say understand spacing. That gets really complicated if you've ever looked that up before. It's, I still haven't found anything that's reasonable or explained right. So I'm still in search for that. And so that's something I have not added yet. So if you type in a letter with or a number with the way the program is right now, it's going to read it. I don't want it to be able to read it. I want it to say only letters. So that's right there. This output here is just telling you how long the actual word is and how long your guess is. So the word is 3 characters long. Your guess, who knows? Now we're going to check for those lengths and say, your guess is either too long or it's too short. So while they're not equal in length, then if your guess is longer than or greater than the actual word, it does this. And so you would subtract however many extra characters from your guess than the actual word to know how many characters the actual word is, and vice versa. Then you've got another way to enter your guess again. We also have to, once again, change it into a form where it understands the length of the word because S2 is character. So I added these 2 lines again inside of that, so now I can read the length of it and check again to make sure they're the same length. So we exit the while loop. Hopefully you are still with me here. This right here is going to compare each letter of your guess with each corresponding letter of the actual word, because you want to kind of give your user help here. There's a lot of words in the English language, and I think it's probably just useful to have this area, this if else, all of this inside of here is just to kind of help them to know how many characters back, like they go through the word and they say the first letter in your word should be 5 characters further in, second letter should be 14 characters back. That's all this is checking for each of that. So we've got if else, because it could be greater than or less than. One of these probably doesn't have to be here, and one of these can probably be taken out as well. Let's see. This, I'm not entirely happy with this, because here's the deal. If you change the word, if you change the length of it, right now it's dog, it's 3. If you change it to like tent, that's 4. You would need to add 2 more lines in here and 2 more lines in here with like a 3 in these spaces. That can get really tedious, and that's a lot of space you're taking up. I feel like the answer is probably going to be in a for loop, but still looking into that, still trying to figure out how that's going to work. It gets really, really complicated. So it's in the making, and once this program is finished and functioning, I'm probably going to put that up in like an extras playlist or something, because I think this would be pretty awesome to have. Let's see, we've got another check for the guess, and then we check for the length of them again, because you might have forgotten, hey, don't enter something that's greater than the length of the word. So that's where we have this again, and then we loop back around to once again check, is it equal to 0, basically meaning are these two equal. If they are, you guessed it, return. So let's go ahead and run this. I'll show you how it works so far, just so you've got proof of this not being like a bunch of garbage and I don't know what I'm doing. It's still half and it's not complete, so I will admit that, but it works okay right now. So let's we know the word is dog, so let's do tent. Okay, so see, there's the output. It's telling me the word is actually 3 characters long. Your guess is 4. Your guess is too long. Subtract 1 character from your guess. So now I'm like, okay, I'm looking for a 3-letter word. Let me try cat. Your guess comes before the word in the dictionary. Move the first letter, and see that's these right here. We're telling each character where to go. That's all of this, which can probably be better done with a for loop, because the for loop is probably going to end up making it possible for me to change that constant up there to however many characters, and then I won't have to keep adding these lines. So let's see. Move the first letter forward 1 character, so that would be a D. Okay. Second letter forward 14 characters. O, and backward 13. So I can't do math. Done. I guess comes after the word in the dictionary. So see if we've seen how it comes before, after. See, both ends are working, and now it's only outputting the 3rd letter backwards 7 characters. Now I can suddenly do math. You guessed it. So that's how the program's functioning right now. Again, keep it simple, because the book is definitely not asking for this. But you can see how realistically it's a very complicated thing. Just for understanding structure, it should be very simple. So here's the flowchart. There's the pseudocode. Anyway, I hope your brain isn't melting out of your head like it is in my head, like my brain is melting. But thanks for watching, and I'll see you in the next video.